So hello, Gregory. Here
Hi.
we are
Hi, Raphael.
once again, again and again, and it's just almost the last one before our great conclusion tomorrow. What I will propose today, because we have explored different angle, we have explored infinity on different angle for the last, but there is something maybe that is missing, and of course it's related to things that we have already said in other session, but I will think that we could focus today on infinity or the infinite in the concrete and the abstract world. Because when we are, I mean, you're a mathematician, of course. So when you are thinking about infinity, you are thinking, I think, most likely of infinity in the abstract world. You are thinking about, Cantor and other things about your omega number that is an infinite number. We have talked about that already, and so this question of infinity abstract, in the abstract and infinity in the concrete, I think it's an interesting question because we also have infinity in the concrete world when we are trying to think, for instance, about the limit of the universe. We are facing some kind of paradox because we say, oh, is the universe finite or infinite? Do we really know what we mean when we say that? Because when we say that, we say, oh, yes, it's finite. But if it is finite, it means there is an end of the universe, so the universe is in something, and this something in which the universe is not part of the universe, but maybe it's not, according to the idea of dimensions and all that. So all that interrelated thing, I mean, I think we have to address that. And the other thing we have to address regarding concrete and abstract infinity is the idea of the mind, like infinite in the mind. Is the mind infinite, or the spirit, or whatever? Or can we simulate concretely, like with machine, the mind? So that will mean the mind is actually finite if we can really simulate it? Or does that mean that even a computer could reach infinity if the mind is infinite and you can simulate it? I mean, all those questions I think we have to address. So first question will be, do you think there is a real difference between empirical concrete infinity and abstract or mathematical infinity in the way you see that?
Well, if you take the ontological position that the world is built out of pure mathematics, then you could have infinity in both places, right? In the mathematical world and in the world of mathematical ideas. But, is space infinitely divisible? Now, also, is the universe infinite or is it finite? If you start going in a certain direction, if it's a four-dimensional sphere, you eventually come back to where you left. There's no boundary, but it's like going around the Earth. You start in any direction, eventually, if you're doing a geodesic, I think eventually you get back to your starting point.
It's true.
And the same thing could happen with the entire universe as a Gedanken experiment.
I know, but
right?
I've never been entirely convinced. Maybe my imagination is not big enough to be able to be convinced, because let's talk about, by these arguments that I heard many times and deployed in different way, because let's imagine, okay, we are talking about the Earth, and you say, yes, you go on one direction, and because the Earth is actually round, and you come back in the same thing, but still, the Earth is in the solar system, for instance, and the solar system is in something. Okay. So will it be possible to imagine that in the universe as a whole being in nothing?
It doesn't need to be embedded in anything.
I have a hard time to...
Well, mathematically, it can be a closed system. It doesn't require, the geometry doesn't require there to be an embedding space. In fact, that's even an issue about whether there are always embedding spaces or not. That was a famous theorem by the gentleman who got the Abel Prize, John Nash. and then got killed going home in a car accident.
Wow.
Poor devil. So
it doesn't need to be embodied by anything.
It doesn't. Yeah, because you see, if you need an embedding space, well, then the embedding space, does that have to be in a still bigger embedding space?
I know, and it's an, as we say, it's an infinite regression into embedded space and embedded space and embedded space and embedded space.
Yeah, it doesn't need to be. It could be mathematically. It's perfectly reasonable to have a finite but unbounded universe. And then if you start off in any direction going in a straight line, you would eventually come back in principle to your starting point from the other direction.
Yeah,
just like on Earth.
I know, but I can't figure out that anyway, because
well, if
Earth,
you work on it, you get a geometrical intuition for four-dimensional objects.
And so you really got an intuition, and you're sure of that. When you look at it, you say, okay, I'm totally convinced that it is actually possible.
Yeah, well, you could start off with a book by George Gamow called 1, 2, 3 Infinity. He talks, you have to develop an intuition for geometrical objects in 4 space, for example. And people who do geometry, I think, and there's intrinsic geometry where it's only this, it's all local. You don't need an embedding space. There may be an embedding space, but...
It's interesting. I think it's interesting what you're saying, because I never heard, I mean, exactly the way you say it, and you said it, and I think it's interesting. It's like doing geometry, it's also trying to be immersed in the world of geometry and get used to it, like someone that will get used to live underwater, or someone that will get used to be in an atmosphere where there are not so much oxygen. Because, and so you need to adapt your own intuition to be able to have the intuition of something you can't really have. There is something that is really not so technical, but the fact that you understand because you were living in the world of geometry, I would say, like in the underwater or something.
Right. So you can take a square, say, start with a square, then you go to a cube. The next step is to go to a hypercube. And there are analogies, and you can count how many surfaces, how many vertices. After a while, it all starts to make sense, and you develop.
Yeah, but the fact of the matter is that even when you're saying that, and when you are talking about the cube, and obviously it's because I haven't been so long in underwater. I mean, living in the world of geometry, so I confess my limitations. But my limitations. Makes me think that even when you're talking about a hypercube and a hypercube and you're adding dimensions, still, when I'm figuring it like in here. So in here, in what you are just there, you know what I mean? And so even if someone inside the hypercube or inside those multiple dimension figure of the finite universe that does not need to have boundaries, and I see that if someone is inside it, it will go in one direction and it will come back. But still, looking at the figure from the outside, like you are figuring it for me, it's in something. It's on the table or it's in there. So I have a hard time to feel. Even after what you told me, and I say again, it's my limitation to feel that it's in nothing.
Well, there's also a book called Flatland, which is a 2-dimensional world.
I remember you were mentioning that in another session.
But what concerns me more is since I work with information that's discrete information, bits 0 and 1, and with algorithms which are discrete. A few of us, including my late friend Edward Fredkin, Stephen Wolfram, myself, other people, we would like to, we think that maybe the universe, maybe time and space are actually discrete, even though they look continuous at the level of everyday life. But if you keep dividing, you would get to atoms of space or atoms of time, indivisible. And as a pre-Socratic ontology, there are certain paradoxes associated just with continuity, just with real numbers, with infinite precision measurements.
That's true.
And to me, a world which is discrete makes more sense. Now, the fact that it makes more sense to me and to Stephen Wolfram doesn't mean that God has decided to make the world discrete.
I also think that, if you can allow me, that if it makes more sense for you, it's actually because you're a mathematician. And so for you, you need to be able to make calculations. And so when you have a world that you imagine is made of bits that are like atoms, as you said, like quantum, basically, like a certain quantity, like discrete quantities, it's easier for you to say, at the end of the day, we can make calculations, stop it with all those bullshit, with continuity and all that, and those paradox. So we can solve them because, in fact, space and time are discrete. But
time can be a computation.
Exactly. But when we do that, I'm afraid. I'm afraid because it's what I see. But again, maybe that's my limitation of my imagination, and I haven't been long enough inside the world of mathematics, like under the sea or something.
Well, to a dentist, everything is teeth.
Yeah, exactly.
And to a computer scientist, everything is discrete.
Exactly. And in Greenland, for the people that live there, everything is snow and white, and so, of course. But I think
But there are 30 words for snow in Finland, right?
Exactly.
They distinguish all kinds of states of snow.
Exactly.